launched just 18 months ago now gets 97 million SDK downloads every single month. And that's the speed at which MCP is rewriting how developers build AI applications. And if you haven't learned it yet, you're already behind. Most chat applications today are islands. They can talk to you, but they can't teach you your files, your tools, your APIs, or your company's data unless someone builds custom bridges every single time. And that's the exact problem MCP was created to eliminate. Anthropic introduced the Model Context Protocol in November 2024 as an open standard for creating secure two-way connections between AI applications and external data sources. The official MCP documentation puts it simply. Just like USB-C gives every device one common way to connect, MCP gives one application a very common way to connect with the tools and data. So MCP went from just 100 servers at launch to over 4,000 by May 2025, and today the ecosystem has grown over 14,000 servers with backing from OpenAI, Google, Microsoft, and AWS. Now, MCP is what makes this practical for Python developers. So instead of writing complex connection boilerplate, you write normal Python functions and turn them into usable tools using simple decorators. The official FastMCP documentation says that the project is downloaded around 1 million times a day, and some version of FastMCP powers around 70% of MCP servers across all languages. Developer tooling surveys show that 42% of MCP builders are already using FastMCP as their primary framework. The 97 million monthly SDK download stat comes from. So here's the one-line takeaway. FastMCP is a Python-friendly way to build MCP servers faster, so your application can safely expose tools, resources, and reusable prompts to any supported client without reinventing each wheel each time. Modern applications are moving beyond static question and answer experiences. Businesses, developers, and learners now need systems that can connect to real information, call real functions, and return useful results. FastMCP is how you build that, faster, cleaner, and without starting from scratch every time. So now that we understand why FastMCP matters and where it fits in real projects, let's quickly look at what we're covering in this tutorial. MCP basics. We will understand what MCP means and why applications need a common way to connect with tools and data. Why FastMCP? We will see how FastMCP makes it easier to build MCP servers using normal Python code. Project setup demo. We will set up VS Code, creating the project folder, installing packages, and preparing the environment. First, FastMCP server demo. Then we will create and run our first basic FastMCP server. Tools, resources, and prompts. Then we will add callable tools, readable course data, and reusable prompt templates. Next, we will test everything using the terminal, FastMCP Inspector, and a simple Python client. FastAPI integration demo. Then we will connect FastMCP with a FastAPI app and test it in the browser. Final project demo. Then we will build a small course assistant server and understand how all parts work together. Before we move on, let me share something really exciting with you guys. If you want to build something strong and practical with Python, machine learning, deep learning, Gen AI, NLP, ML Ops, and intelligent control systems, then you should definitely check out the Professional Certificate in Generative AI, Machine Learning, and Intelligent Control Systems by IITM Pravartak in collaboration with Simplilearn. What makes this program really useful is that it's not about learning concepts, but about applying them through the live online classes, expert-led sessions, hands-on projects, and real-world causes. The program includes 18 plus industry-aligned projects, 3 capstones, 25 plus industry tools, and 30 plus AI and ML skills, so learners can actually build a strong portfolio when understanding how these skills are used in real businesses and automation problems. You also get masterclasses by IITM Pravartak faculty, eligibility for 2-day campus immersion at IIT Madras Research Park, and a program completion certificate from IITM Pravartak Technologies Foundation and Simplilearn. Along with that, you get exposure to tools like Python, TensorFlow, Keras, FastAPI, Docker, Hugging Face, LangChain, MLflow, Git, Gradio, OpenAI, Pandas, NumPy, Matplotlib, and more. So whether you're a developer, a working professional, or a data learner, or someone planning to move into future-ready tech roles, this course can help you gain practical confidence, build real projects, and prepare you for opportunities in AI, automation, and machine learning. You can find the course link in the description box below. Before we move on, here is a quick quiz question to check if the core idea is clear. So what is the main use of FastMCP? Is it A, to edit videos, B, to build MCP servers, C, to design websites, or is it D, to store passwords? Let us know your answer in the comment section below. In this FastMCP tutorial, we're going to learn how to build a working MCP server using Python. So before we start coding, let's understand the big picture in a very simple language. Imagine you're using a chat application and you want to do more than just answer questions. So you wanted to read course details from a file, call a calculator function, search through a catalog, or prepare a learning plan using your own data. So normally collecting all of these things separately can become very confusing because every tool may need a different setup. So this is where MCP comes in. MCP gives us a common way to connect a supported chat application with external tools and data. And FastMCP makes this process easier for Python developers. So instead of writing a lot of complex connection code, we can write simple Python functions and make them available as tools. Today, many developers are not just building normal chat-based apps. They are building systems where a chat application can connect to real tools, read useful data, and complete simple tasks. So this is why MCP is becoming a trending developer topic. The official MCP documentation explains it like a common connector that helps applications connect to external systems in a very standard way. So now, let's first understand what MCP means, why MCP is useful, and how that basic flow works. After that, we will move into the main demo, where we will create a project folder, install the required packages, write our first FastMCP server, add tools, add resources, add prompts, test everything, and finally connect with FastAPI. So now that we're clear about what we're going to learn, let's move on to the main problem. A normal chat application can answer questions, explain concepts, and generate text. But in real projects, we often need more than just that. We may want the application to read local file, call a company API, check a database, search a product cat, or trigger a small workflow. The challenge is that each of these systems may work differently. For example, connecting to a file system is different from connecting to a database. Connecting to a calendar is different from connecting to a GitHub repository. Connecting to a FastAPI app is different from connecting to a simple Python function. So if we build a connection separately, the project becomes hard to maintain. MCP solves this by giving us a common structure. So think of it like a standard connection method. So once a server follows the MCP format, supported clients can understand what tools are available, what input each tool needs, and what output it can return. So this is very useful for developers because they don't have to explain everything manually every time. So the server itself can describe its tools, resources, and prompts in a structured way, so the client knows what it can call and how to call it. So MCP was introduced to reduce the need for separate custom connections for every tool or data source. So instead of building a different connection for every service, developers can use one standard approach. So in the demo, we will use this idea to build a course assistant server. The server will expose tools like course search, course recommendation, and study plan calculation. So it will also expose course data as a resource. So this will help us understand MCP in a practical and beginner-friendly way. So now that we know the problem, let's move on to understand how MCP works in simple terms. So now that we understand why MCP is needed, let's look at how it works. We will keep this thing simple and connect it directly to the demo we are going to build. So there are three important parts in the flow. The first part is client. So this is the application that wants to use a tool or read some data. So this is what we will build using the FastMCP. The third part is actual logic. This logic can be a Python function, a JSON file, an API, or even a database in a larger project. The flow is pretty simple. The client asks for something. The flow is very simple. The client asks for something. The server receives that request. The server checks if the tool or the resource is needed. Then it runs the correct function and reads the correct data. After that, it sends the result back to the client. So let's take an example from our project. Suppose a learner wants to search for cloud-related courses. The client can call for our course search tool. The MCP server receives the request and passes the keyword to our next Python function. The Python function then checks the course catalog and returns the matching course details. So in MCP, we mainly work with three things. The first thing is tools. Tools are actions. For example, search courses, calculate study time, or compare two courses. The second is resources. Resources are data that can be read. For example, our course catalog can be exposed as a resource. The third is prompt. Prompts are reusable message templates. For example, we can create a prompt that prepares simple learning paths. So MCP is not something we need to overcomplicate. For this tutorial, just remember the simple line. The client asks and the server handles. The Python function runs and the result comes back. So now that the working flow is clear, let's move on to why FastMCP makes that easier for Python developers. So now that we know what we're going to build, let us understand how we will test it and why safe usage matters. First, we will test from the terminal. So this is useful because we can quickly check whether the server is running and whether the tools are listed and whether each tool returns the expected output. Then we will use commands to inspect the server, list available tools, and call tools directly. Next, we will use the FastMCP Inspector. So the inspector gives us a visual way to test the MCP server. So this is helpful for learners because they can clearly see tools, resources, prompts in one place. So instead of guessing whether the server is working, we can open the inspector and test each part step by step. After that, we will connect FastMCP with FastAPI. Many Python developers already use FastAPI for web applications. So this section will show how an existing FastAPI app can work with MCP. So this is important because in real projects, we may not always start from zero. Sometimes we already have APIs and we want to make them available through MCP. So MCP is powerful because it connects applications with tools and data, and this also means developers must be careful. So official reference servers are meant for learning and examples and not direct production without use of proper safeguards. We will also discuss some common errors. For example, FastMCP may not be installed in the correct environment, the JSON file may be missing, the server file may be running from a wrong folder, or the resource URL may simply be typed incorrectly. So these are the simple mistakes, but they can confuse beginners. So we will cover how to fix them. Finally, we'll be talking about safe usage. So since MCP servers can connect to tools and data, we should not expose sensitive files, private keys, passwords, or unsafe system commands. For this tutorial, we will keep the project safe by using a small local course catalog with a simple Python function. Hey everyone, and welcome back to Simplilearn. In this FastMCP tutorial, we're not going to stop only with theory. We are going to build a working MCP server using Python, test it from the terminal, test it from a browser-based inspector, and then connect it with a FastAPI. And finally, build a small course assistant project. So the goal here is simple. By the end of the video, you should understand how FastMCP works and how to create your own working tools that a supported chat application can call. So now before we write any code, let me first show you what we're going to build. So we will be creating a project called FastMCP Simplilearn demo. So inside this project, we will create a FastMCP server. So this server will first have a simple greeting tool, and then we will add course resources, reusable prompt templates, a FastAPI integration, and finally a complete mini project. For this demo, I will execute everything inside VS Code. So as you can see here, I've opened a new folder named FastMCP Simplilearn demo, and all Python files like basic server py, course MCP server, test client, and JSON file will be created inside the same folder. So all of the installation commands, FastMCP commands, and Python run commands will be executed in VS Code terminal and not in a separate tool. So whenever we need to test the FastAPI app, we will run it from the same terminal and open the browser at a given URL. So whenever we need to visually test the MCP server, we will use the FastMCP Inspector from the terminal and then it will open the browser. So throughout this tutorial, the main place that we will use are VS Code for writing code, VS Code terminal for executing commands, and browser for testing FastAPI and MCP Inspector output. So now that we know what we're building, let's move on step by step and set up the first project. So to begin with, let's try to understand the flow of using our own project. First, we will keep this simple. So think of it in three parts. The first part is called client. So this is supposed to be a chat app, an editor, or a testing tool. The second part is an MCP server. So this is where we're building our FastMCP. The third part can be actual logic. So this can be a part of the Python function, a JSON file, a database, or an API. So in this particular demo, the flow will be something like this. The client asks for something, the FastMCP server receives the request, the FastMCP calls the correct Python function, and the Python function returns the result. And finally, the FastMCP sends the result back to the client. Now, let's connect this project to an example. So if a learner asks for beginner-friendly cloud courses, the client can call our search courses tool. So the FastMCP server receives that request, and then it runs our Python function. That function checks the course catalog and returns matching courses. So now we will create three main things in this video. First, we will create tools. So tools are functions that can perform an action like searching a course or calculating learning time. Second, resources. Resources are read-only data. For example, our course catalog can be exposed as a resource. Third, prompts. So prompts are reusable instruction templates. For example, we can create a prompt that asks the chat app to generate a learning roadmap. So now that the flow is clear, let's start the setup and create our working project. So now that we're clear about the structure, let us set up everything required to run the demo. So I'm going to use VS Code and a terminal. You can be using Windows PowerShell, Command Prompt, Mac Terminal, or Linux Terminal. So these commands are almost the same except the virtual environment activation command. So first, let me create a new folder for this project. So as you can see, I've used the command make directory FastMCP Simplilearn demo in order to create a new folder. So in this command, I have created a clean folder and it has moved us inside it. So keeping a separate folder is important because all of our Python files, JSON files, and requirements will stay in one place. Now let me go ahead and create a virtual environment. So as you can see, I've used this particular command. So a virtual environment keeps this project packages separate from other Python projects. This avoids version conflicts. So now let me go ahead and activate the virtual environment. So this is the command I've used for Windows. So if you're using Mac or Linux, Prior to this command, just add the word source. So once the virtual environment is active, I'm going to upgrade pip. So let me go ahead and show you how to do that. So let me go ahead and upgrade pip. So for that, let me type python-m pip install followed by upgrade pip. So now let me go ahead and install the required packages. So for that, I will type pip install FastAPI UVCon. So here FastMCP is used to build the MCP server. FastAPI is used later when we connect our MCP server with a web API. So UVCon here is used to run the FastAPI application. So now that we verified our FastMCP, so now let me go ahead and type FastMCP version. So fast version. Make sure that there's no gap between fast and MCP. So if the installation is correct, the command will show the FastMCP version. So as you can see, we can see the version number here. Now let me go ahead and create a requirements file so that anyone can install the same packages again. So for that, let me go and type pip freeze requirements.txt. So this creates a new requirements.txt file. So if someone else wants to run this project, they can install everything using this command. For that, let me go ahead and type pip install -r. So now that the setup is complete, we can start writing our first FastMCP server. So now that the environment is ready, let's create our first FastMCP server. So I will be opening this project folder on VS Code. So as you can see, I've opened the project folder on VS Code, and inside VS Code, I'm going to create a new file called basicserver.py. Now let's go ahead and add the first version of the server. So within this folder, I'm going to add from fast import fast followed by MCP equals, So now let's go ahead and understand this code. So the first line here imports FastMCP. So this is the main class we use to create an MCP server. This particular line from FastMCP import FastMCP, the name here helps us identify the server in which we inspect or test it. And the last part runs the server when the file is executed directly. So this particular line of code is the standard Python pattern. So it means if we run this file directly using Python, then we can start the MCP server. Now let's go ahead and run it. So move back to your terminal here and type Python basic server. So at this point, the server starts, but it doesn't really do anything useful yet because we have not added the tools, resources, or prompts. So here I will stop the server using Ctrl+C. So now let me go ahead and inspect the server. For that, I will type this command. So that's fast inspect basic. So this command reads the server file and shows what it contains. So right now, it's supposed to show 0 tools, 0 resources, and 0 prompts, which is as shown on the screen over here. And that is expected because it's only an empty server. So now that we have created our first server, let's move ahead and add our first tool. So now that our server is running, let's make it useful by adding tools. A tool is not just a Python function that a server exposes. We will start with a simple greeting tool and then add more useful course-related tools. So for that, you go ahead and open basicserver.py and replace the code with this. From FastMCP import fast. So now let's go ahead and understand this code. So at first, we create the server here. Then we define the first tool by adding @mcp.tool. So this particular function which I've highlighted over here takes the learner name and returns a greeting because it has an MCP tool. So FastMCP exposes it as a tool. The second tool here is calculator, as you can see from this command. So in this particular command, it takes 2 integers and returns their sum. And the third tool calculates study time. And in this final command, we return a dictionary. So this is useful because the output is structured. It clearly shows daily hours, number of days, and total learning hours. Now let's go ahead and inspect the server again. So let's go back to our terminal. FastMCP inspect basic server.py. And this time the output should show 3 tools, as you can see over here. So now let's go ahead and list the tools in a cleaner way. For that, I will type FastMCP.py. So this particular command shows the available tools and their input details. Now let's go ahead and call the first tool from the terminal. And that is FastMCP call basic server. We also follow it up with a line called greeting learner name, and you can add a name within quotes. And this should be returning a greeting. So as you can see, we have our output over here, which is hello Bharat, welcome to our FastMCP tutorial by Simplilearn. So now let's go ahead and call the calculator tool. And for that, I'm going to use this command. For that, I will go ahead and type the following command. So that's FastMCP call basic server followed by this line. And that's the add numbers function followed by the numbers. Let's say, for example, A is equal to 10 and B is equal to 20. And this is supposed to return us the number 30. So as you can see, we have our result over here, which is 30. So now let's go ahead and call the learning hours tool. So for that, let me go ahead and type fast call basic server.py. So I've called the next tool in this particular command, which is FastMCP call basic server.py, followed by the line calculate learning hours and hours per day. I've also entered the details for the same. And this particular command should return the total learning hours as 75. So here is our output. So now that we have successfully created and tested tools, let us move on to resources. So a tool is used when we want to perform an action, and a resource is used when we want to expose read-only data. For example, a course catalog is a good resource because the client can read it. First, let's go ahead and create a course catalog file. So in the same project folder, create a new file called course catalog.json. So as you can see, I've created a file name called course catalog.json, within which I will go ahead and add this particular data inside it. So as you can see, I have my data over here. So now let's go ahead and update the basic server.py so that it can read this file and expose it as a resource. So replace basic server.py with this code. So let's move on to basic server.py and replace it with. So now that we pasted this code here, let's go ahead and explain the new paths. So first, let's import two extra modules, which is import JSON path. From path lib, import path. So the JSON module helps us read and write JSON data. The path class helps us work with the path file safely. So now let's define the file location. So as you can see in this line of code, it means that the code will look for course catalog JSON in the same folder as basic server.py. Then let's use a helper function. So as you can see, this def load catalog function here is called as the helper function. And this function opens the JSON file and returns the course list as a Python data. Now let's go ahead and look at the first resource. So as you can see, when a client asks for a catalog all, this function runs and returns the full course catalog. Now let's look at dynamic resource. So as you can see over here, your course ID here is a placeholder. So here if the client asks for Python basics in the course catalog, FastMCP passes Python basics into course ID parameter. So now let's go ahead and inspect the server. So let's move back to our terminal and type this FastMCP basic server.py. Yeah. So this should be showing us tools and resources, as you can see over here. Now let's run the server through the inspector so we can visually test the tools and resources. So for this, let me go ahead and type FastMCP dev inspector basic server.py for st. So when the inspector opens, choose stdio if required. So now that our server can run tools and expose course data, let's go ahead and add prompts. So a prompt is a reusable message template. It doesn't perform an action like a tool. Instead, it prepares a clear instruction that the chat application can use. So now let's go ahead and open basic server.py and replace the code with this particular version. So I've opened basic server.py here. Let me go and clear this. So now let's go ahead and see what changed. So we added a new tool called search courses. Search courses over here. This particular function which I've highlighted here takes a keyword. Then it checks the title, category, level and description of each and every single course. So if the keyword is found, it adds the course to the results list. Now let's go ahead and look at the prompt. So as you can see, this is the prompt and it's called create a simple learning plan for a level learner whose goal is followed by the entire prompt. So this particular prompt accepts a goal and a level. So this returns a ready-made instruction and the benefit is consistency. So instead of writing the same instruction again and again, the client can reuse this prompt whenever needed. Now let's go ahead and inspect the server. So let's move back to our terminal and type FastMCP. Now let's go ahead and type FastMCP basic server.py. So as you can see, the server showed us the tools, resources and the prompts. Now let's go ahead and add the list what the server should expose. So now let us also list what the server exposes. So for that, let me type fast list basic server. So now that we have added the tools, resources and the prompts, let's go ahead and test everything properly. Yeah. So as you can see, our server has all three parts. So now let's go ahead and test it from different places. First, we will test it from the terminal. Then we will test using an inspector. Then we will create a small Python client file. So now let us first call the search tool. So let's type FastMCP call followed by the search courses keyword is cloud. So as you can see, this command returned the cloud and DevOps essential courses. So all of the details here from ID, title, category, level, everything has been mentioned here. So now let's go ahead and search for a beginner course. For that, I used this line of code. I've used search courses keyword beginner and this should be returning multiple beginner level courses, which is as shown over here. Now let me go ahead and test the learning hours tool again. So as you can see in this command, I've added the hours per day as well as the number of days. When I go and run this, it should return a total learning hours which is as predicted. Now let's go ahead and create a Python test client. So create a new file called testclient.py and add this particular code. So as you can see, I've created a testclient.py file over here. So the code for this is import async.io from FastMCP, import client. Then let's add a main function which is async main. So now let's go ahead and understand this particular client file. The first line here imports async.io. So FastMCP client operations are asynchronous, so we can use async.io to run them. Then we import client. So in this particular line, I've imported client. So the client here connects to our MCP server. So inside the main function, we connect to the basic server.py, which is as shown over here. Then we use this particular block. So this particular block of code opens the connection properly and it closes properly when the work is done. So the ping here checks if the server is reachable or not. Then we list tools called tools, list resources, read resources, list the prompts, and then finally get a prompt. Now let's move on to basic server.py over here and replace it with the following version. So as you can see, this is the complete version of the code within the basic server.py. Let's move on to our terminal now and run this command. So now let's go ahead and run basic server.py. So as you can see, we see greet learner, add numbers, calculate learning hours, and search courses. Now let's go ahead and run test client. So let's type the command client.py. So since everything is correct, we should be seeing tools, search results, course catalog data, and prompt output. So everything is as listed and is correct over here. Now let's go ahead and reconnect FastMCP with FastAPI. So now that our MCP server is working, let's go ahead and connect the same idea with FastAPI. Now this is useful because many Python projects already use FastAPI to create web APIs. And with FastMCP, we can expose a FastAPI app through MCP as well. So go back to VS Code here and create a file called FastAPI MCP app.py and add this particular code. So let me go ahead and show you how to understand this file. So first, we import FastAPI. So from Pydantic, we import base model, and from FastMCP, we import FastMCP. Then we create a course model. So as you can see here, we created a course model. So this particular model defines the structure of one course. Then we create a simple in-memory database called CoursesDB, which you can see over here. So for this demo, I've kept it very simple, but in a real project, this data may come from a database. Then we create a normal FastAPI app. So with this block of code, which you can see here, we added 3 API routes. The home route checks whether the API is running. The course route returns all of the courses. And the courses/course ID route returns one particular course. Now comes a really important part, which is this line of code here. This block of code here converts the FastAPI app into an MCP server. Then we add one extra MCP tool manually. So as you can see, we have the block of code here which represents the tool. So this shows that even after converting a FastAPI app, we can still add custom MCP tools. Now we created an HTTP app for MCP. We can represent that with this block of code. Now the lifespan part here, which you can see, is important because it helps the MCP server start correctly inside FastAPI. Now let's go ahead and run the FastAPI app. For that, we run this line of code, which is uvicon FastAPI MCP app followed by reload. So while this happens, open this in the browser. So once the application startup has been completed, let's go ahead and open this in the browser. So go ahead and open a new tab. And now this shows the normal FastAPI Swagger documentation. Now let's go ahead and test the API routes. And this should be showing us all of the courses. Go ahead and open a new terminal and run. So we move here, we open a new terminal here. Let's go ahead and move into our folder, which is CD followed by the course name. Then let's try moving into the environment, which is .venv. So now let's go ahead and test the MCP endpoint from another terminal. For that, I will use the following commands. As you can see, this particular line of code should list the tools exposed through MCP endpoint, which is as shown here. So as you can see, there are a total of 4 tools over here, which is get course count, home, list courses, and even get courses. So now that we have connected FastMCP with FastAPI, let's quickly cover some common errors learner may be facing. This part is important because many tutorials skip mistakes, but during real practice, these errors happen very often. So I've just randomly opened a file named errors and I will show you the basic errors which can be made. So the first error here, as you can see, is the module not found error. And the error here is no module named FastMCP. So this usually means that FastMCP is not installed in the current environment. So the fix here is to activate the virtual environment and install the package again. So as we've already done this, you will have to move on to Windows and type pip install FastMCP. So this will be the command in order to fix the error. The second error is FastMCP is not recognized. So this usually means that the command line cannot really find the FastMCP command. So first you will have to check that the virtual environment is active, and then you're supposed to run this command, which will be python m pip install FastMCP followed by FastMCP version. So if this particular command still doesn't work, close the terminal, open a new terminal in the same project folder, and then activate the virtual environment. After doing that, you can run the command. So the third error is running the command from a wrong folder. So if we run this particular command, but the terminal is not inside the project folder, Python cannot find the file. The fix here is to move it into the correct folder. So as you can see, we've used the cd command followed by the name of the file, and then we used FastMCP inspect basic server.py. Now the fourth error is forgetting if the name is equal to main block while we are running the file directly with Python. So this code creates a server, but running python basic server.py will not start anything because there is no run command. So as you can see, this particular line of code here, which is from FastMCP import FastMCP, and we have the name as correct example. So this line of code over here can be replaced with a corrected version, which is as shown over here. Now the fifth error is the JSON file is not found. If the code says file not found, it means that the JSON file is missing or not in the same folder as the Python file. The fix here is to keep the course catalog JSON in the same folder as basic server.py. The sixth error is a wrong resource URL. If the resource is defined like MCP resource catalog course ID followed by this line of code, which you can see over here, then this particular URL is correct. But the URL is wrong if it's in this way, as highlighted over here. So the URL must match the pattern defined in the code. Now the seventh error can happen in a FastAPI integration if we forget the lifespan while mounting or combining the MCP app. So now this is not the recommended pattern. So as you can see, when we have app followed by app mount, so in our combined example, we used this particular line, which is MCP app is equal to MCP HTTP app, followed by the title over here, the version, roots, and even the lifespan. So this particular line helps FastMCP start correctly inside FastAPI. So now the eighth error can happen inside the inspector if the dependencies are missing. So since our project has a requirements.txt file, we can run the inspector like this. The block of code is mentioned as follows. So now that we have learned tools, resources, prompts, testing, and FastAPI integration, let's finally build a small mini project. So now this will be a Simplilearn course assistant MCP server. So this will be reading all of the course data from a JSON file, search courses, recommended courses by goal, calculate study time, expose the full catalog as a resource, expose a single course as a resource, and provide a reusable prompt for learning plans. With all this combined, let's create a file called coursemcpserver.py. Now let's move on to VS Code and created a file called coursemcpserver.py. Now go ahead and add this complete code. So for that, let's import JSON, path lib import path, and we also import FastMCP. So as you can see, this is the block of code for the same. So now that that's done, let's go ahead and finally understand the project. Now the server starts from here. So the instructions text here explains what the server is used for. Now the following function here, which is def load catalog, is used to load the course catalog. So now this keeps the code clean because every tool can reuse the same function. Now the search courses tool over here, it searches for the keyword. So now the recommended courses tools recommends the courses based on the learner's goal. This is the entire block of code for the same. Then we have the calculate study plan tool, which calculates how many weeks a learner may need. And this particular tool over here, which is called the compare courses tool, it compares two different courses. The resources over here, which you can see, expose read-only course data. As you can see over here, which we have done in the previous sections, and I have already told you this, the prompts here create a reuse template. So now that I've given you a run through of the complete final project, let's go ahead and test it. Move back to your terminal. Let's first start with inspecting the server. So let's go ahead and type FastMCP inspect. So upon running this line of code, now we will list what the server exposes. So first, let's go ahead and inspect the courses. For that, I've used the FastMCP inspect course MCP server.py. So now let's go ahead and list what the server exposes. And for that, I use this line of code, which is FastMCP list course MCP server.py. So following that, we now call the course search tool. The line of code is here as follows. So now that that has been done, we will call the recommendation tool. Now that we have the data displayed for this as well, I'll go ahead and calculate a study plan. And for that, I call this line of code. Now let me go ahead and run this. Okay. Now let me go ahead and compare both the courses. Now let's go ahead and open the inspector. So typically once that's run, we can test each tool one by one. Search for the data courses, recommend a course for the cloud, calculate a study plan, read the full catalog resource, read one course resource and check the available prompts. Now let's go ahead and test this final project using Python. For that, let's go ahead and create a file called testfinalproject.py. So let's move on to VS Code and add this line of code. As you can see, I've imported async IO here. And then from that, FastMCP import client. And from that, I've imported client. So now that I've added the line of code, let's move back to our terminal and execute the final line of code, which is Python test final project. Yeah. So now if everything is correct, the terminal will show us the connection message, available tools, course search result, course recommendation, study plan calculation, resource data, along with the prompt output. So we have all of our data over here as required. So now that we have completed the full working FastMCP project, we have started from the setup. We created a basic server, added tools, added resources, added prompts, tested everything, connected it with a FastAPI, fixed common errors, and built a complete project. And that we have completed our demo on FastMCP. And that brings us to the end of this FastMCP tutorial. We started with the basic idea of MCP, understood why MCP is useful, and then built a strong working project step by step using Python, tools, resources, prompts, testing, and FastAPI integration. And the main takeaway is this: FastMCP helps developers connect applications with real tools and data in a cleaner and easier way. So keep practicing the demo, try adding your own tools, and experiment with your own project ideas. Subscribe to Simplilearn for more such insights and check out our related videos.